It's called the gradient, right? So gradient of f is, so I'll write this as, I'm going to use this symbol. Okay. This also belongs to Rn, right? It's a bunch of n vectors, right? This is a gradient is also a vector. Okay. I know how to take the second derivative. So what is the second derivative of f? F of x1 through xn. How do I write the second derivative? What is that called? Okay, you will get 1 mark provided you answer this. Then probably hope, do you remember? Laplacian, no? Huh? Hessian, right? Yeah. So it's called the Hessian, right? So what is a Hessian? So essentially, there are n variables. I can take the second derivative with respect to each one of them. That gives me the diagonal, right? So dou f or dou x1, right? So you get the first derivative and so on. The second derivative, right? The second of n, xn, right? And then what about this second term? This is with respect to x1 and then with respect to x2, right? And so on. And similarly, you know how to fill this, right? This is called the Hessian, right? It's a n cross n matrix, right? Linear algebra will help us analyze these things. We'll see how to do that later on when we deal with what is known as convex functions, right? So essentially, the ijth entry of this is basically dou square f over dou xi dou xj. Okay, this is the ijth entry. Okay, so there is one more very important result. I'll just state this without proof. It follows from what is called the fundamental theorem of calculus. It's called the remainder form of Taylor series. You know what a Taylor series is, right? Everyone knows, right? F of x, you can expand it around a. You have f of a plus x minus a into f dash of a plus x minus a whole square, f double dash of a by 2 plus and so on, right? So there is something called remainder form of Taylor series. Can somebody tell me what is remainder form? I'll write the scalar version first. So for example, I'm looking at f of x. It's a mapping from R to R. I can write this as, I'll write it around a. F of a plus x minus a into f dash of a plus x minus a whole squared by 2 factorial into f double dash of a star for some a star in the domain of f. Okay, you know what the domain is, right? Set of all x which gets mapped under f, right? That is your domain. Okay, why is this true? Any idea? Can you guess why is it true? Well, I'll pictorially show it for the first order, not the second order. So let's say you have a function which maps, let's say this is your function, okay? Let's call this is some, let's say I'll call it as capital A and capital B. This is your function f, x. So what is the domain of this function? Can somebody tell me? What is the domain of this function? A to B, right? So now I want to look at a point, let's say somewhere here, okay? This is x. I want to see what is f of x, right? How do I write f of x? Well,